What if this small subwoofer can deliver all the bass you desire? This is the T6 compact tone subwoofer. It is very nice and it is very small. It is designed to have a sound similar to the larger compact tone models. I will reveal some of the secrets in achieving that addictive bass from this very small package. A visitor liked the sound from the compact tones, but he didn't want refrigerators in his living room. This makes sense. Easy to place, looks great, doesn't take up a lot of space. But does it work? We will get into that. But first, let's design it. Some sacrifice surely cannot be avoided, but imagine having that same addictive bass character from that small package. Maybe it doesn't need to play that loud, or go down low into the infrasound range. Reasonably loud, 30 Hz is sufficient extension downwards. 30 Hz, it sounds like this, if your speakers or headphone can reproduce it. 30 Hz extension is a very good choice for extension for a subwoofer that isn't meant to be extremely loud and can cover almost all normal music content. If we look at this album from Affected Mushroom, it's called, the track is called Avrat. It's a piece that contains very heavy and deep and powerful bass transients, so it's used by audiophiles often to demonstrate performance in the bass range. But the bass transients, they only reach down to around 30 Hz. And if we have 30 Hz extension, then we can cover all of this. That's amazing. Also, if we look at how we hear, if we lower the frequency, we see that the sensitivity for the sound goes down, so that we need a higher sound pressure level to be able to hear anything at all. And in most music content, we see that the energy at very low frequencies, it usually drops down quite a bit. So that unless you play extremely loud, there is no content below 30 Hz that you can hear or perceive. And we can utilize this to our advantage. So we can make a subwoofer that can cover down to 30 Hz properly and cover everything that is audible in the bass range. Reasonably loud, that is 100 dB at 30 Hz. I can't demonstrate that because I can't control your volume. 100 dB, what is that from the subwoofer? We try to look at it in the context of how we hear, how we perceive loudness and sound, and how loud we play. If we play at live concert level, that is around 0 dB on the master volume on a calibrated system. And with this loudness, we usually have around 90 dBs of sound pressure level at the listening position. That is the average level. The peaks will tend to rise up to 20 dB louder, so we need 110 decibels to cover the peaks. 2 T6 subwoofers will then sum up so that it adds up to around plus 5 to 6 dB. So let's say we have 106 dB but that is at 1 meter from the subwoofer. But in a room, we have an amplification, a gain of the lower frequencies due to acoustic effects and reflections inside the room. So the bass will usually be much louder inside the room, and especially at the distance from the subwoofer, the loudness will be much louder than compared to if the subwoofer was placed on a football field in free field, so there are no reflections around. So we usually end up a little bit higher than this 1 meter at the maximum. So let's say we can reach up to around 110 decibels at 30 Hz. And that is then sufficient to cover music played at concert level. And that is quite amazing, especially considering the size of the T6 compact horn subwoofer. And to make the sound right, it needs acoustic loading. It's from this opening, the sound comes out. It's a very small opening compared to what we usually see when we talk about bass horns. They are huge. This is a very small one, but it works similar in principle to a very large bass horn. This acoustic loading, it also makes it possible to shape such as the frequency response. How is it possible to fit a 30 Hz horn inside this tiny box? Size of the compression chamber determines the horn length, so that if we increase the compression chamber, it's the chamber behind the cone of the driver, then the size or length of the acoustic channel can be reduced. Then we reduce the cross-section area. So now we have a shorter length, we have a smaller cross-section area, so we can fit it into this box. Inside here we have the chamber, and then we have this horn channel, goes around there and eventually comes out here. There is also an additional acoustic channel inside with a carefully dimensioned damping at the entry, which causes removal of the resonance that occurs due to this loading with a smaller cross-sectional horn, because then we will have a mismatch in acoustic impedance loading, and this causes the horn to have a very uneven frequency response. But the compact horn technology with this damping channel, it fixes that. We tune this system, the channel, the cross-section area, the amount of expansion from the throat. The throat is smaller than the mouth, but it's still very small. And the size of this limits the maximum achievable acoustic output. So this small port opening, it is just large enough to support 100 dB at 30 Hz. So why is size connected to output capacity? It has to do with the volume velocity, that is the flow, amount of flow and the speed the air flows back and forth when it reproduces the lowest frequencies. Because if the channel is more narrow, then it cannot support so high velocity compared to a wider channel which can support higher velocity. We understand that the velocity has to increase a lot to be able to move the same amount of air. So we have two things going against us. The smaller cross-section area increases the speed of the air, and the smaller cross-section area supports even a lower maximum velocity, especially around the exit of the mouth. Here, when this becomes turbulent and you get flow separation and very high losses. It works fine up to some sound pressure level, but then when it reaches this maximum capacity, it will fall apart and you get very high losses. A horn system like this will then perform similar characteristics to a small ported box, which has the same problem. The port and the channel here, it becomes sort of an obstruction, so the air, it stops, can't move. So essentially, if you push it hard enough, it will be similar to a sealed box. This affects output capacity, and it creates distortion, and it changes the frequency response. So we need to dimension for the maximum desired output capacity. Shape is a rectangular box. It has this square shape and the driver is recessed with the port opening out. That is why it's called a T6. The T models, they have this configuration with the port opening, horn opening, close to the cone, and the cone, the driver is recessed like this. It gives the subwoofer a nice and interesting design. It's not like those typical subwoofer. A typical subwoofer is a square box. It's nice when it's placed flat on the floor, and it can also be placed upright like this, and it can be placed upright and face the listening position. Looks very nice. And it can be placed upwards towards the wall, like this, if I am the wall now. It has a built-in amplifier, which you can't see because of the lighting. Now you can see it. And this is a 2-channel amplifier. It is programmable with a DSP. So it's possible to set up and tune and calibrate the bass system properly. But the thing is with this subwoofer, since it's born with a flat frequency response, it's very small, so it's easy to place it correctly. It makes life much easier when you calibrate and set up the system. In some installations I have seen that there is barely any need for any EQ at all. Of course, in many rooms you have at least one huge room resonance, and even the T6 cannot magically remove that. But we can magically remove it in the DSP, of course. But in some rooms, like one system, it was set up and installed into the room, and there was no need to do any EQ on the bass system. So it worked right out of the box. I also have customers who have bought the system and they don't want to do this calibration and programming and microphones. Turn it on. Does it work? Yes. Sounds great. And in some cases it actually does. Performance can be verified. We can measure it. And we can compare it to other small subwoofers. Pay attention to frequency response, output capacity, and group delay. And you compare the graph from this T6 subwoofer to other commercially available subwoofers. Find the test. I will put the link to one in the description. What is missing? You don't get that massive, powerful impact, that smack. The sense of danger, as one visitor described it. The larger models, they have some of that. Depends on the setup and room and system. In the right conditions, they have actually quite a lot of that. But you don't get that from this small package. There is simply not enough output capacity. It cannot play loud enough. For many use cases, though, it can play plenty loud. And that is what the T6 is made for. We can see the T6 as an exercise in product development. Yes, it is possible to create a bass system that can play louder, better in any way, but here it is about creating a product that is adapted and customized for and made for a specific purpose, and create an elegant solution. So if you can have all the bass you desire in this small package, achieve almost everything of the addictive bass sound and bass character of the larger systems, then that is a great achievement, and it is a good product design. But why bother with this then? Because a similar sized box, it could fit perhaps a 10-inch woofer. Then if you have a very powerful amplifier, you can have a small volume and play quite loud. Perhaps get a similar performance output capacity at down to around 30 Hz. You need some DSP to shape the frequency response and so on, but never mind that. That is possible. But why? Well, if you're going to make something, why don't you do it properly? Make something interesting and exciting. It is harder to design. It is a little bit harder to build, but once you have the manufacturing set up, it doesn't really make that much of a difference. The cost is mostly the exterior finish. That's the same. So it won't be that much more expensive. And the sound will be different. You put in a bit more effort into creating the product, into the design process, to get something that is a little bit more exciting, a little bit more technology built into the product. Because you're going to use many, many hours sitting listening to music, enjoying the bass sound out of this. So you deserve to have something that is properly designed, is exciting as a product, as well as exciting in the way it actually performs and sounds. There's no point in making something mediocre. This is an exercise in a better way to design the product and create something that has a better value. The visitor who did not want refrigerators, he bought 2 T6 instead. So it works. It definitely works.